Good morning. In this video, I'm going to go over 4.6 part 2. I'm probably going to just go through a few examples because there's a lot of them. Probably the ones at the end that were more difficult. Just following these notes that I sent out with your points on the parent functions of the cosecant and secant graphs. If we look at these, number 17 and 18, the only difference with these from our parent function is these values out in front. So we still have the same x values here because there's no shift left and right. There's no b value to stretch our graph. So all we're worried about is basically the a value, the altitude of our graph. Also, this is negative. So normally on our secant graph, if we look right here, normally this is up here at 1, but because this is negative, it is going to shift down into the bottom of our graph. Also, because it is 1/2, rather than going down to -1, it's just going to go up to -1/2. Same thing follows here. This one's normally negative. Now it's going to come up into the top of our graph at 1/2. With the second one here, it is positive secant graph. So it starts at the top, then the bottom, top, and so on. Again, we only are going to go to 1/4 because we have that a value out here in front. Number 21. Okay, this one has pi inside of our function. That is our b value. So what that is going to change is our period, 2 pi over b. So we get the period of 2. That is going to change where our key points are. That's only going to change, really what that's going to change is how long the period is. It's not shifting left or right, so we're still starting at 0. It's just changing the distance between each point and how far the one period goes here. The points are still vertical asymptote up at 1, vertical asymptote down at -1, vertical asymptote. Moving on, okay. Number 22 also has that b value in here. So when we find our period, we do 2 pi over 4, which gives us pi over 2. Okay. And then finding our key points, dividing that by 4, gives us pi over 8. Then also here we just have the 3 out in front, which is going to stretch our graph by 3. So instead of having it here at 1, it's now going to be up here at 3. And instead of -1, it's going to be down at -3. Again, there's no horizontal shift to our graph, so it follows a similar way. These next ones are pretty similar to that one above, so I'm not going to completely go through these two. I will post a picture of this answer key on Google Classroom to help you with that. I want to move on to the more difficult ones. Number 25 is also pretty similar, it just has a b value. Here we have to be careful knowing that the b value is 1/2 and not 2, so that makes our period 4 pi. Okay, so our key points are going up by pi each time and following the normal points on our parent function of cosecant. Okay. Same thing for this next one, the only difference is it's 1/3 as our b instead of 1/2. Moving forward to number 31, these are the ones I'm going to go through, 31 and 32, because these are the first ones we've looked at with a phase shift, all right, with the c value. We can see here that we have minus pi inside of our function, so we know that that is actually going to shift to the right by pi, okay? Which we can see here when I came up with my starting point using this right here, starting point, where is this? Starting point bx minus c equals 0, all right? Here we have x minus pi equals 0, and we get pi being our starting point. Okay? Our period doesn't change here because there is no b value in this. Okay? So you could say starting at pi, if I add 2 pi to that, we are ending at 3 pi. And then we find that our key points are at every pi over 2, basically by dividing our period by 4. So then we can come up with these points based off of that. We also have this 2 out in front, which just means that instead of this point being here at 3 pi over 2, 1, it is now at 3 pi over 2, 2. And then same thing with the ones on the bottom, they are at -2 rather than -1. And moving on to the last problem we have here. Cosecant of 2x minus pi, this one has a b and c value. So our period is going to change. We are going to do 2 pi over 2. The 2's cancel out, we just get a period of pi. Then when we come up with our starting point and end point, 2x minus pi equals 0. If we solve that, we get our starting point at pi over 2. Then 2x minus pi equals 2 pi. When we solve that, we get our end point of 3 pi over 2. Okay. Then we come up with our points in between by adding pi over 4 each time, and going back to our original parent function to figure out where we have a vertical asymptote, where we have a max and min. You'll notice that early on I wrote max and min for these, or the other way around. I don't care whether you call these a max or min, whatever you are more comfortable with, because it might be weird to write this as a min and this as a max when this point is actually higher up than this one. The reason that this is a min, this point here, is because it's a relative min. Everything around it in that interval is greater than it. For this point here, everything around it is less than it. That's why we call it a max. If you want to call it something else, you can. I think these are just easy to put here as relative min and relative max. I just posted 4.6 part 3 on Google Classroom. So it's a worksheet with one of each of the 6 trig functions. And that is due Monday the 23rd at 11 a.m. I will post a few examples of me going through some of those today as well.